26 is the next problem. If I want to take a derivative, I'm treating this, so remember, we said this is a radical. If I ignore that completely, that's a square root. It's worth memorizing. Derivative of that is 1 over twice the square root of whatever that is. By the chain rule, you're going to multiply by the derivative of this. You could also write this as t over t squared plus 4 to the 1/2. Bring the power down, subtract 1 from the power. That's going to give you this. Times the derivative of the inside, and that requires the quotient rule. Derivative of the top times the bottom, minus the top times derivative of the denominator, all over the denominator squared. That's good enough. You could, in the homework, you're going to clean everything up. For the exam, that's fine. Next problem, problem number 30. I would say s prime is going to equal 1 over twice the square root of 1 plus the sine of t. Again, what you did there, you treated this as a power function. You brought the power down, subtract 1 from the power, times the derivative of the inside. Well, derivative of the inside requires the quotient rule. Derivative of the top is the cosine of t, times the bottom, minus the top times derivative of the denominator, which is negative sine of t, all over the bottom squared. And that would be it for a test. On the homework, you're going to clean that up. Okay, on the next problem, again, you're going to look at this as the tangent of n theta squared. So j prime, bring the power down, subtract 1 from the power. Now the outsidemost function is the tan. Derivative of tangent is secant squared of whatever that is, times n. This worth doing again. I could say, let me start with letting u equal the insidemost function. That is n theta. Okay, that's taking care of it now. And let v equal the tangent of, it should be n theta, but it's going to be u. And j will equal v squared. And now if I say find the derivative of j with respect to theta, right there, which is what this is, guess what? I'll say j depends, let me stick with the colors on this one. I could say j depends on v. Automatically, v depends on, I love it when the colors don't change. Oh, they did change. V depends on u, and automatically u depends on theta. I used blue twice, that's what's confusing. So at any time I could cancel those, and I can cancel those, and I'll get the change of j with respect to theta. And now I could do this in moderations. The derivative of this is simply 2v. The derivative of this is simply secant squared of u. And the derivative of this with respect to theta is simply n. Replace u back in, replace v back in, and you will get that. That would be twice v. V would be the tangent squared, the tangent of u, but u is n theta, and remember that's being multiplied by the secant squared of u. And what was u again? U was and theta again, and multiplying that by n. So bottom line, you need to be able to do this, and I have a few examples for you to make sure that you could do that. This problem is another example. If I want to take a derivative of this, the outsidemost function, oh man, what's with the colors today? The outsidemost function is to the fourth power. Bring the power down, subtract 1 from that. Copy this down. Times the derivative of this. Well, inside I see two things. Derivative of this and derivative of that. Derivative of the second piece is 3. That's simple. But the first, I notice that has a power function of its own. That right there is a power function by itself. Bring the power down, subtract 1 from the power, times the derivative of the inside. I have all of this space, and I don't know why I'm squishing this. And there it is. Something you should definitely practice. Okay, the next problem. I'd like to take a derivative of this. Well, I could say I'm gonna take derivative of the top times the denominator minus the top times derivative of the denominator. Bring the power down, subtract 1 from the power, times secant squared of x. This is the chain rule, all over the denominator squared. Now remember, you can be cleaning this up on the homework. Or, can't I rewrite this? Can't I take... Oh, never mind. Or, I put the or in the wrong place. Or I could write y equal, if I move this up, isn't that 1 plus tan of x to the negative 2? And when I take a derivative, wouldn't you say bring the power down? Subtract 1 from the power. Times the derivative of the inside. There it is. So either or, it makes no difference. 52. Find the equation of the tangent line to the curve y minus y1 equals m into x minus x1. There it is. And it's not going to get old. You're going to do that in almost every section. What's missing? The slope of the tangent when x equal 2. What's the derivative? 1 over twice the square root of 1 plus x cubed, because that's a radical function, times the derivative of the inside, which is 3x squared, and automatically throw the 2 in. What do you get? You will get 3 times for a 12 over 2 times, if you put a 2 in there, that's 8 plus 1, 9, square root of 9 is 3. That is 12 over 6, which is a 2. Done. That simple. And number 64, let f and g be functions. Find me a derivative evaluated at 2 for a. Well, f prime of x is f prime of f of x times f prime of x by the chain rule. If I evaluate everything at 2, put a 2 there, then I'll get f prime of 2 to equal f inverse of f of 2 times f prime of 2. And let's make sure we're getting that correct. I need two values. I need f of 2. There is f at 2 it's a 1. And there's f prime at 2, it's a 5. And now what is this saying? This says, this is a 5 that's fixed. This says, go to 1, there is 1, and find me f prime. F prime is a 4. And that turns out to be a 20. Let me restart this again. Now to do this piece. If I take g prime of 3, well, g prime of x is going to be g prime of g of x times g prime of x, but it's going to be a 3. The same deal. This is g prime. I need to know what this is. And I need to know what this is. This, x equal 3, there's x equal 3. G is right there. That's a 2. However, g prime is right there. And that is a 9. And this is, go to g prime, but a 2. There's 2. Where's g prime? That's not a, nope, it's right there. G prime is a 7. And 7 times 9 is a 63. And that's pretty much it. And there's the homework.